All right, guys, let's talk about the quantum model of the atom. This is sort of the most recent model of the atom that we work with. It's probably the most up-to-date model of the atom. And it's similar to what we already know about atomic structure. And this, remember, is a Bohr model of an atom. And the quantum model is related to the Bohr model for sure, and we'll talk about how the word quantum is tied to this idea of the Bohr model. Okay, we're gonna refer back to Bohr models quite a bit here as we talk about the quantum model of the atom. Okay, so the first thing you really need to do, I think, when you learn about the quantum model of the atom is to have a really good understanding of the periodic table of elements. And the periodic table is divided in many, many different ways, actually. From this stair-steppy line here, left is all metals, and then on the other side is non-metals. That's one way of dividing it. Another way of dividing it is by columns, and by rows, and then by these blocked out color neighborhoods that I've made you here. And that's what I want to talk about first. So the first two columns, of elements, these are collectively known as the S block. The S block. Okay, and so you'll see why that is the case here in a second. But let's just move on to these other colors here. All of the stuff in the red is known as the D block. And then everything here in the yellow is referred to as the P block. Okay. Oh, and then this little goofy neighborhood down here, these elements that are down here in green, this is collectively known as the F block. F block. Okay, and so we're going to use these neighborhoods pretty frequently to understand how electrons fill into energy levels in a Bohr model. Okay, the other way we need to understand how to divide a periodic table up is by rows. And we know what a Bohr model is, and we know that these rows of elements, 1, 2, 3, 4, 5, 6, and 7, we know that we've called those energy levels in the past, and the entire second row, for example, comprises these elements here, right? So that's known as the second energy level. And in a Bohr model, those energy levels or rows, they correspond, as you know, to these different energy levels here in the model, right? So the first level is just the first level here. The second level that I drew the line through, that's the second level. Third level is the third level, and so on, okay? Now the quantum model, that's where we start making some changes to what we know about the Bohr model, okay? So to really get the quantum model, we gotta just have an understanding that the arrangement around the nucleus of its electrons is pretty complicated. Electrons are on those energy levels, and the energy levels are deceivingly simple in a Bohr model, and they get a little bit more complicated in the quantum model. Okay, the quantum model of the atom divides each energy level into sublevels. Okay, and so let's stop right there and look back to the periodic table. When we say that each level is divided into sublevels, we're talking about these S and P levels, okay? So the second level is divided into an S sublevel and a P sublevel. The third is divided into an S, a P, and then we're gonna find out that it's actually down here in the D block as well. And so each of these rows of elements is divided into at least, well, the first one is only one sublevel, an S, but then every other level beyond that is divided into these S, D, P, and F sublevels of the energy level, okay? And within those sublevels, we have things called orbitals, okay? And orbitals, this is a tough one for kids, but let's talk about what orbitals are. So in our four types of sublevels, there is a specific number of orbitals that can be contained within a sublevel. And an orbital is just like sort of it's a three-dimensional space around the nucleus where an electron can be within that level. Okay, and so each orbital can only contain 2 electrons, and that part's tough. Okay, so let's talk about the sublevels here. So the S sublevel contains only only one type of orbital. That's called an s orbital. And that s orbital holds only 2 electrons. And that should hopefully make sense because in our Bohr model, in our first energy level, we can only hold 2 electrons. That's because there's only one sublevel within that energy level, and it can hold a maximum of 2 electrons in one single orbital, okay? The P sublevel. Now the P sublevel, if you remember, the P sublevel is 6 elements across from column 13 all the way to column 18. That's 6 columns of atoms, and so those 6 columns, they need 3 orbitals to contain those 6 electrons. Remember, every time we move across the periodic table, we add 1 electron to the atomic structure, right? And so those 6 electrons, knowing that only 2 can be held in 1 orbital, we require 3 orbitals, and they're just called p orbitals. And then D, this is where things get a little bit goofier. D contain 5 orbitals. They're just known as d orbitals, and they can hold up to 10 electrons. And so when we look back to the D block of elements, we see that columns 3 through 12 here, that's 10 atoms across, 10 elements across, and each time we move down the periodic table, we add 1 more electron for a total of 10. And so those 10 electrons get held in 5 orbitals, each orbital holding 2 electrons, okay? And then our F sublevel, these guys down here, they contain 7 different orbitals because we have 14 elements that we have to account for in each sublevel. And so each time we go across the periodic table, we're adding 1 more electron to the atom for a total of 14 new electrons here in the sublevel. And those 14 electrons have to be held in 7 orbitals because each orbital holds only 2 electrons, okay? So let's look at the Bohr model in a kind of a different way here. So this is part of a Bohr model, and let's imagine that this dot over here is your nucleus. In our first energy level, we have just one S sublevel, and that goes back to the periodic table, knowing that the only thing in the first level is the first S sublevel. And you'll notice that I've moved helium over to this side here. Its electrons, it belongs here for a couple of different reasons, and it belongs over here for a couple of different reasons, but it is an S block element, okay? So just think of helium over here as an S block element, okay? So the first sublevel contains 1 S orbital and 2 electrons maximum. Now the second energy level holds an S sublevel and a P sublevel, and that's the one that we drew the line through, right? So we have an S level and a P sublevel, and in those we have just a single S orbital, 3 P orbitals, and that holds a total of 8 electrons max. So 6 from the P orbitals and 2 from the S orbital. And then in our third energy level, we have the 1s, 1s here. We have, or excuse me, the 3s, and then 3p. And then also, kind of confusingly, but you'll see why, the D, or this D level down here, this is actually the third D level. And so the third level is organized into an S orbital, 3 P orbitals, and 10 D orbitals for a maximum number of electrons in the third level of 18. The fourth and the fifth level behave pretty much the same. They all have an S orbital, 3 P orbitals, 10 D orbitals, and 14 F orbitals for a maximum count in the fourth and fifth energy level of 32 electrons. Okay. Now we do get out beyond the fifth energy level, and if we do, which we do occasionally, this is what we've done so far. Here's the sixth level, and now we start actually losing sublevels from the periodic table. In the sixth energy level, we only have an s orbital, p orbitals, d orbitals, and that's a maximum of 18. And then down here in the seventh, way out far from the nucleus, different periodic tables will state this in different ways, but we definitely have an s orbital, and there could be these. So this is a more modern periodic table, and we do see that the 7 exists in the s and in the p. And believe it or not, this line here is not part of the 7th level. I know that's confusing right now, but hopefully it won't be here before too long. All right, so the 7th energy level holds a maximum maybe of 8, but for sure 2, okay? So that is the quantum model, and I want to kind of demonstrate how this stuff works here. So atoms are 3-dimensional, so we have an x and a y axis, and then we have a z-axis as well. So imagine that z-axis coming out toward you and then back into the paper as well. And so the way that this works is we start off from the very bottom energy level, and I'm going to call this the 1s orbital, okay? So this is the very first orbital that we're going to see. Now, I'm assuming that we're going to just keep adding electrons to this model, but there's a maximum of 2 electrons in this orbital. The next orbital to fill is the 2s orbital, and the s orbitals are this spherical shape, and so if we completely filled the first and second s sublevels, we would have a total of 4 electrons. Here's where it starts getting a little bit goofy. And I'm going to go back to the periodic table here. Where is that? Here it is. So we're just going down the periodic table, and we're filling in according to energy level and sublevel. So right now we've covered the first S sublevel, and next thing we get to on the periodic table is this 2S sublevel. And then we get over here to the 2p sublevel. And those orbitals look a little bit different. So each one of these shapes I'm going to put on here contains 2 electrons. And so here's what they look like. This is the shape of a p orbital. I hope you can see that okay. It's sort of a figure 8 sort of looking thing. And they fill into the same energy level, but there are 3 separate p orbitals, right, that arrange themselves along the x, y, and z axis. And so that takes care of filling in those 6 electrons in the second energy level right here, okay? From atomic number 10, which is neon, next place we get to is atomic number 11, sodium, and we're back to the s block. So the s sublevel, that third sublevel of s, goes over the top, and that's the same shape as the other s orbitals. And then the next ones that fill in as we go across here from atomic number 12 to atomic number 13 is our p. And the p's look just like they did in the second energy level. They fill in the x, y, and z orientation. And they just kind of keep building like that as you get farther and farther out. And remember, this is all in 3 dimension. I do want to say that the F and the D orbitals look really strange. I'm going to show you what they look like. So here's a picture of the F orbitals. So I'll do the D orbitals first, actually, of which there are 5. So here's what the D orbitals look like, and they're pretty complicated looking, and they fill in just the same way that our P and S orbitals did, with these spaces all containing 2 electrons max. And then the F orbitals look even funnier. These guys are pretty complicated looking, and but the thing is, each of these structures here contains a maximum of 2 electrons. Okay, so I didn't want to cut those out, but they would pile on in specific sequential order as well. Okay, and so I hope that helps you understand the quantum model of the atom. And in the next video, we'll talk more about how this quantum model can be used to explore the electron arrangement of an atom. Okay.